Hello, my name is David Curran, and today I'm going to talk to you about data visualization, particularly around telecom, that sort of data, but mainly just about how you can go out there and start creating visualizations and what you should do. So let's get started on this. So, anyone recognize this graph? You might be able to guess where it's from, what it's for by the end of this talk. So visualizing trends and loudness in popular music. That was a paper I wrote. Which was in the Journal of General Internal Medicine, ended up in Forbes and a few other newspapers. But it wasn't really a paper I wrote. What it was actually was a graph I made for a laugh. It got third prize in this SciPy John Hunter Award, which was good fun, made a few quid, and it's nice to have your name on something like that. But realistically, what do you have to do to make a visualization? You need to get some data, you need to code it up, possibly make some tweaks and improvement. There's a series of steps you go through making these graphs called the grammar of graphics, and I'll go through that today. So by the end of this talk, I want you to have a good idea of, oh wait, I can go off and I can make a graph that looks pretty, I can show it off. Lots of places to get data. Anyone here at the TAD conference is going to know, going to have access to an awful lot of data they need. But if you don't, there's plenty of public data sources out there to go and find data in a particular topic or area. There's no problem anymore finding data. Where do you get ideas for visualizations, even example code? There's various websites, or bloggers is a great one. If you do a search on Twitter for a particular hashtag like ggplot2, which I'll explain there in a minute. There again on Reddit, there's certain subreddits that people put up visualizations and usually the code they use to make them, which is really great for learning. And also, there's plenty of examples out there. If you just do sort of searches, image searches on Google for graphs, you can find plenty of stuff. Okay, so how did I make this particular graph, the one I'm talking about today? I was searching on Twitter and there was this interesting post about when people go doing sports. Oh, it's interesting. I hadn't seen that sort of graph before, or I had on that first picture, the album cover, but didn't know that you could, they were easy enough to make and they could be used for different things. So saw that, liked it, remembered, stuck in the brain and said, oh, if ever at some point in the future, I might try and make a graph like this. So I made a graph of how long songs stay in the Billboard Top 100. So that they stay longer over the period of time. Not a great graph, not very good colors, not even a particularly interesting topic. Songs spend longer in the top 100 than they used to. Okay, fair enough, but it's not really that interesting. And then I saw a visualization of the million song data set. Now, interesting, this is a visualization, I can't really understand it. I'm looking at it, I don't really know what it's showing and why. But still, a million songs sounds like a really interesting data set. Do I know anything where that data could be used with a visualization technique I know, and the two can be combined in an interesting way? And that reminded me of the Joyplots issue. So, find data, have a skill or have a type of visualization you know how to make, and eventually the two will sort of combine together. So I made this visualization of beats per minute. It's a bit more interesting graph. Oh look, it seems to be that songs are getting slightly faster over time, and there seems to be now two kinds of songs, whereas before there was sort of a mass. I haven't actually explained how you read these graphs. Basically, the size of the bump is how many songs meet those criteria, and if it's well spread out, each particular beats per minute is fairly common. If it's very humpy, large hump, it means only the songs focus around one particular kind of beats per minute. Right, so I made that graph, put it out there. People gave me advice of, oh, I think this is wrong and that is wrong. Have you thought about this, or are you sure about that? And that happens with visualizations. It's one thing the community is great about, possibly two great, is they're going to tell you how to go fix things. And then I thought, wait, loudness in song is kind of interesting. Loudness is it's a weird kind of a scale. It's logarithmic for a start, and also it's negative in the sense of loudness here means the difference between the loud bit and the quiet bit of the song. If you notice now, songs tend to be very punchy for the radio, whereas before they weren't that punchy at all. Okay, that's quite an interesting graph. Now, it shows that the difference between quiet and loud has changed over time. So one thing, my background is purely as a coder. I'm not really an artist or anything like this. So I think one mistake sort of tech people like us make is that we think art is sort of springs out of the ground or something, that it's not really based on past experiences and what other people have done and stuff like this. So a very good book on this is Steal Like an Artist, where it just explains that no, art doesn't work like that. It is a bit like tech in that you're just using what other people have built before and trying to build on top of it. There's a famous jazz trumpeter who said, imitate, assimilate, innovate. Copy what someone has done, learn how to do it yourself, and then when you're happy and you know how to do that, try and apply it to something new, to something different, change it a bit. But learning how to do something and just copying that is fine. You do admit it, you don't try to make money off it, anything like that, but you are allowed to just learn skills and build up your sort of portfolio of skills. David Bowie was famous for it. He just, everything he had was just in stone, which is, and then combined in unusual ways. So it's some passing here. Anyway, so for those who didn't realize this, that picture at the start is a picture of Quasar, how often they rotate, and it was used for the front cover of Joy Division's Unknown Pleasures album. It's a great album. But it was a scientific visualization that got used as an art visualization, if you know what I mean. So the physical mechanics of making visualization are worth knowing. Now, I'm using a language here called OR package and a particular library called ggplot2. If you know Python, matplotlib is fine to use. There are other libraries out there. There's plenty of JavaScript ones for making interactive graphs. But I like OR package, I like ggplot2. It works for me. First of all, find the data. Again, anyone in Telecoms is going to have a hell of a lot of data somewhere. Make a simple graph. So there's nothing wrong with making a bar chart. Probably is something wrong with making a pie chart. But make a simple graph to understand what's in the data, what's it showing you, that you have got the data in a decent format, that it's not full of blanks and these sorts of things that happen in all data manipulation. Make an ugly graph, that's fine. If you have an idea in your head of a kind of graph you want to make, it's fine to make that graph, but not pretty. You will get errors a lot of the time, matching up the types of the data or blanks and these sorts of things. And Stack Overflow's your friend here. A lot of people have been through these errors before. Any mistake you've made, lots of people have made, and you can fix it based on their advice. Then there's all the stuff around the labels and the title and the themes and all this sort of stuff. And this takes a while. It's kind of fiddly, putting in the examples, moving to the left a bit, moving away a bit, but it's not massive brain work. It takes a while, but each step of it is fairly simple. And none of it's like exhausting to use your brain. It's just something, the steps you have to go through. There are other tweaks you want to make where you sort of add colors or changes or spread things out more than that. Those sort of tweaks, again, they take some time, but it's kind of fun work. It's not really difficult because at this point you've got something you like and you're just trying to make it better, and that tends to be quite easy to do. Color, of course, is important. You want to make any of these graphs pretty. Other than that, you can just use a bar chart or whatever like that. So it is worth putting some effort into thinking about the colors, thinking about how it's going to look. One thing that's easy to forget about is colorblind people, particularly for some sort of working graph. It's very common, colorblindness. So it's something to remember always that, you do want to tend to take pictures. Keep it in mind, colorblindness, basically. Okay, so go make a picture. There's loads of other kinds of plots out there. Raincloud plots here. It's a different graph I made. Heat maps, sorry, forgot the name of it, heat maps here. I tend to make a lot of graphs on climate change, just showing the data, because you are kind of telling a story with a graph. They're not entirely by opinion or anything. There is a story in them. What data you pick, what data you try and show. All data is opinionated, as they say. So graphs are a good way to get an awful lot of information across quickly. And that's why I try and make climate change graphs a lot of the time. So here, for example, I'm showing the sort of temperature in central England, which has data going back a long time. It's shown sort of an upward trend recently, these sorts of things. Now, telecom. This is a telecom conference. I think it's worth talking about some of the telecom use cases. Common things you want to graph in telecom are like just descriptions of the data. What do the people look like? Who's in the data? What are they like? People are always talking about dashboards and sentiment analysis and stuff, and I just don't actually think they're that common or useful. So I'm not going to talk about them today. Churn and upsell. I used to work for Amdocs, and a lot of the sort of analysis I did was on these topics, and it's very interesting. It's quite easy to find interesting data in it. Churn in particular, people who churn can jump out at you as different from how they use the phones. A really common thing with churn is social networks. If like the main person you phone changes, you're probably going to change. I think we've all learned recently how important social networks are and how connected we are to people and what effect that has. And it's just something that's worth remembering. If you're doing visualizations, those sort of graph visualizations of who you're talking to and why is a good way to show who's going to churn. There are, of course, other kind of churn visualizations where like you're trying to show off the decision tree you're using to decide if someone's going to churn and these sorts of things. These are good ways to explain to the boss why you're making a decision, and you know it's just a nice thing to be able to show them. Now, one thing in telecom I think is really important are maps. There's huge amounts of data on where people go, where your coverage is good, where data is used, all sorts of physical geographic information is available to telecom people and telecom operators. I'm not going to talk today too much about making maps, but I think if you do want to learn how to make maps, a great place to learn is every November, Toppy has a map challenge. Go here to this location he describes it, where people make maps some of the days, you know, parts of the days. They all use a hashtag on Twitter, and a lot of people put up the code they've used. So if you're interested in learning map making for telecom data or for any other reason, I would go to this challenge, look at the hashtag, look at what the data people put up. A lot of people use a geographic tool called QGIS. Some people use Python, some people use OR package. Have a look at the code, copy, learn how to do something, and then you know in future, right? Even if you make a graph about, say, water, something that isn't, you know, particularly interesting to telecom people, if you learn a skill making that map, when you get a new telecom data set coming along later, you'll be able to reuse that data and that skill and be able to make a really nice map really quickly. So if you are interested in telecom visualization, I think that map challenge in November would be a really good place to start. Okay, that's it. Hopefully that was reasonably interesting to you. What I want to get across is you have the data. You can learn the skills quickly by just sort of seeing what other people are doing, copy them, and then you'll know the skill. And then when you get a new kind of data or a new sort of challenge that comes across, you'll be able to put the two together and go out there and make a nice visualization, put it up there. I've had ones using ads, I've had, you know, ones that became popular, these sorts of things. And it's just a useful way to tell a story to people in a visually arresting way, and one that hopefully, you know, is persuasive as well. Okay, thank you very much, and hope you have a good rest of the conference.